The galaxy that shouldn't exist. How James Webb is rewriting the story of the universe. The discovery that shook the cosmos. In a quiet corner of the night sky, a routine observation turned into a scientific revolution. The James Webb Space Telescope, JWST, humanity's most powerful eye on the universe, has captured something that simply should not exist, a galaxy named CRS 2112 that looks strikingly similar to our Milky Way, yet it existed just 1.9 billion years after the Big Bang. This seemingly innocent discovery is anything but. According to current cosmological models, such a well-structured, mature barred spiral galaxy should take several billion years to form. Galaxies in the early universe were expected to be chaotic blobs of stars, misshapen, merging, raw, and unruly. Instead, CRS 2112 is perfect, balanced, harmonious, a cosmic contradiction. And it's changing everything. A universe that doesn't fit the script. Since the early 20th century, scientists have pieced together a powerful narrative. The Big Bang, the cosmic dark ages, the formation of the first stars and galaxies, and the slow, steady evolution of the cosmos over nearly 13.8 billion years. This model has worked incredibly well. It's backed by cosmic microwave background radiation, redshift measurements, large-scale structure surveys, and more. But suddenly, James Webb is uncovering objects that do not align with the script. Galaxies that are too big, too bright, too complex, and too old for the time in which they appear. CRS 2112 is the most stunning example. At a redshift of 3, placed at around 11.7 billion years ago, this galaxy doesn't just contain mature stars. It has spiral arms, a central bar, and organized structure that current physics says should take 5 to 10 billion years to develop. So what happened? CRS 2112, the impossible twin of the Milky Way. Dr. Luca Constantin and his team at the Centro de Astrobiologia, CAB, CSIDNTA in Spain weren't expecting to find a cosmic revolution when they pointed Webb toward a relatively unremarkable patch of sky during the Cosmic Evolution Early Release Science (CRS) survey. They were studying faint galaxies from the early universe, looking for the chaotic beginnings of galactic formation. What they found instead was order. CRS 2112 is around 30,000 light-years across, roughly one-fifth the size of the Milky Way. It weighs in at about 10 billion solar masses, with an astonishing star formation rate of 20 solar masses per year, 20 times the rate in our own galaxy. These are numbers you might expect in a young, active galaxy, but not one so beautifully, inexplicably structured. According to conventional wisdom, such spiral and barred shapes result from billions of years of gravitational interactions, mergers, and internal instabilities. You need time, mass, and dynamical evolution. But CRS 2112 had none of these advantages, and yet there it was, a fully formed spiral beauty in a universe still in its infancy. A crisis of cosmology? The implications are staggering. If galaxies like CRS 2112 could form so early in cosmic history, then our understanding of how matter clumps, collapses, and evolves must be flawed, or at least incomplete. Did galaxies form much faster than we thought? Are the laws of gravity or cosmic evolution different than we assumed? Is the universe older than we currently believe? Or is there something deeper? Perhaps a previously unknown force or field shaping the cosmos in ways we cannot yet comprehend. This is not the first JWST anomaly. Webb has already uncovered massive galaxies just 300 to 500 million years after the Big Bang, and supermassive black holes with masses exceeding 1 billion suns in a time too short to have formed naturally. These discoveries aren't just anomalies, they're a pattern, suggesting our entire cosmic timeline may need to be recalibrated. How barred spiral galaxies form, or so we thought. Barred spiral galaxies, like our Milky Way, are not just beautiful, they are complex and mature systems. Their central bars are believed to form from dynamical instabilities in the rotating disk of stars, where gravitational forces align and amplify, creating a stellar superhighway through the core of the galaxy. But forming such a bar requires a stable disk of stars and gas, enough time for resonances to form and amplify, and often interactions with other galaxies to trigger structural instabilities. All of this takes billions of years, according to simulations. CRS 2112 challenges this. Its early bar formation suggests one of two possibilities. Galactic bars can form much faster than we thought, perhaps driven by internal self-organization or early cosmic conditions we don't yet understand. Our physics is incomplete, and either our simulations or our theories, including gravity, dark matter, or even the timeline of the universe, are wrong, rethinking the cosmic clock. So what are scientists doing in response? They're not panicking, they're rethinking. Dr. Constantin and others are exploring new models of galaxy formation, including early inflow of gas along cosmic filaments. If gas flowed rapidly into the centers of young galaxies, it could ignite starbursts and early disk formation. Magnetic field dynamics. Largely ignored in early cosmology, galactic-scale magnetic fields could play a critical role in organizing matter early. Self-organization theory. Just as trees or corals form naturally beautiful shapes without human design, galaxies may organize into complex forms more easily and quickly than expected. Modified gravity models. Some even speculate that general relativity might need tweaking under extreme conditions, especially if dark matter or dark energy influence galactic development differently than assumed. None of this means the Big Bang is invalid, but does mean that our picture of the universe's early years is changing fast. The eternal universe? One radical implication of these findings is the idea of an eternal or cyclic universe, one that never truly began and may never end. If complex galaxies and massive black holes were already present when the universe was supposedly just a few 100 million years old, then perhaps the universe had a much longer prelude. Perhaps the Big Bang was not the beginning, but a phase transition in a deeper, timeless cosmic cycle. Some theories, such as loop quantum gravity, the epirodic model, or conformal cyclic cosmology, already explore these ideas, proposing that the universe reboots after vast periods of expansion and collapse, or that our current Big Bang was not the first. We don't know the answer yet, but what we do know is this. James Webb is showing us that the universe is more complex, more beautiful, and more mysterious than we ever imagined. Beyond the science, philosophical ripples. When you challenge the foundations of cosmology, you also challenge our sense of place and purpose. If the universe isn't as random or primitive as we thought, could be more ordered, more structured, even purposeful? Are we seeing natural laws playing out, or could there be a deeper intelligence or organizing principle? The idea that galaxies form like flowers or corals, with natural elegance and precision, leads us to deeper philosophical questions. Is the universe alive in some way? Are there patterns of intelligence embedded in the cosmos? Could we be standing on the threshold of a new kind of science, one that unifies physics, information, and consciousness? A new golden age of astronomy. We are witnessing a cosmic upheaval, not a destruction, but a revelation. The James Webb Space Telescope is not confirming our theories. It is challenging them, compelling us to evolve our understanding of the cosmos. As we uncover more galaxies like CRS, 2112, perfect, complex, and ancient, we may find that the universe is not what we thought, and that's a good thing. Because every great leap in science begins with a mystery. Stay curious. Stay open-minded. The universe is speaking, and thanks to James Webb, we are finally beginning to hear it.